thing, and it is called a parallelogram. A parallelogram. First of all, a parallelogram is going to have four sides. Parallelogram will always have four sides, which means it is in fact a quadrilateral. So it's a quadrilateral. Oh, that's erasing. There we go. It's a quadrilateral. But that just means it has four sides. Quadrilateral just means four sides. So it's a quadrilateral, is a parallelogram if opposite sides are, this is going to blow your mind, parallel. Yup. And if you ever forget how to spell parallel, there are parallel lines in the word parallel, so it should have 2L. So what that means, opposite sides are parallel. So HG must be parallel to EF. So whenever I say something's a parallelogram, it's always a good idea to just draw on there that, hey, I have two parallel lines. Now the other pair are also parallel, HE and GF. Here's what I don't want you to do. I don't want you to mark it just like that. Can anyone tell me why that is 100% wrong, Labib?
Because then that means that HE is parallel to HG.
Yep, it means all four of them are parallel, right? So instead of just putting one arrow, we're going to put dose arrows on HE and GF. Two X's? No, those are upside down V's. All right, symbol. Geometry, they make symbols pretty easy. When I'm drawing a line, we just draw a line on top of it. If I'm drawing an angle, we draw an angle. If I'm drawing a triangle, we just draw a triangle, A, B, C. The symbol for a parallelogram is just drawing a very particular parallelogram that looks something like that. That symbol automatically means parallelogram. So the name of the parallelogram up here, what we're going to do is kind of just like triangle. We're just going to draw a little parallelogram, and we're going to name it. I was terrible with my line tools. Let's make that a little better. Yeah, close. All right. Not close enough, though. It just irks me that it's just a little bit off. Yeah. All right. Parallelogram. Naming is just like a triangle. You pick a letter, and you either go clockwise or counterclockwise from that letter. So we could name this parallelogram HGFE. We could name it HEFG. We could name it FGHE. The only thing you can't pick for a name is you can't name it EGFH because that's not counterclockwise or clockwise. So let's just pick someone pick a letter up there. We'll start with that one. Sangha. F. So we'll start with F. Someone pick a direction, counterclockwise or clockwise. Just yell it out. Clockwise. All right. If last time I checked a clock, our next one would be E, H, G. So this symbol automatically means it's parallelogram. All right, this is our symbol for parallelogram. Know that. Because there are stuff where I'm just like, prove that it equals this. And that's saying, prove it's parallelogram. All right, so we have parallel sides makes a parallelogram. Four sides, four parallel sides. Well, two pairs of parallel sides. All right, that leads us to our theorems. Once again, on this sheet, you are allowed to draw on them. You don't have to draw on them now. You might want to draw on them later. You might want to take some time and draw it perfectly, but you're allowed to draw on these. That's why you have that nice little space there for each one. So theorem 5.1, it just says that opposite sides of a parallelogram are congruent. So in order for opposite sides to be parallel, let me rephrase that. In order for opposite sides to be congruent, it has to be a parallelogram first. So I have to say something is a parallelogram. I have to tell you it's a parallelogram. If I just give you a quadrilateral, you don't know opposite sides are congruent. So it has to be a parallelogram to start off with. So that has to be your given. So if I'm looking at a proof, you're looking at, did they give me a parallelogram? And if so, then I can say opposite sides are congruent. So then I can make my little tick marks. I can go my EF is congruent to HG. So we can say down below, that would mean that EF is congruent to HGTV. And we can also say that HE is congruent to GF. But we must know it's a parallelogram first. We must know it's a parallelogram first. All right, theorem 5.2. Once again, it has to be a parallelogram. And that one says opposite angles of a parallelogram are congruent. So let's go ahead and draw that. So if it's a parallelogram, once again, I'll circle that because it has to be a parallelogram first. We can say angle E is congruent to angle G. And angle H, I'll put 2 tick marks because they're not congruent to the other ones, is congruent to angle F. Angle H is congruent to, yeah.
So, would there be any theorem that would prove that same side angles are equal to 180 degrees?
That is true. We don't have a theorem that states it here, but we do have a theorem that says that same side interior angles equal 180 degrees, right?
Yeah.
So that's really important to say, and we can put it right there. Angle G plus angle F, what is that going to equal? 180. So maybe this is a good place to put that. We'll put it in another place too, but I mean, these are same side. Those are same side interior. So that must mean that angle G plus measure of angle F equals 180 degrees. Well, that's important. That means I just need to know one angle of a parallelogram, and I know all the other angles. Because if I say this is 30 degrees, if this one's 30 degrees, what's the measure of H? Sangha? 150. What's the measure of F? 150. What's the measure of G? 30. You just need to know one angle of a parallelogram, and you actually know all the other angles. Because if they're across, they're congruent. And if they're consecutive, that means EF or EH, they equal 180 degrees. And that's because of the same side interior. So although there's no proof that we have with parallelograms, you just have to know what parallel lines do. But it's a good job. Yeah?
So you could extend those.
Yes, we could absolutely extend those lines to see that these are transversals. All right, 5.3. 5.3, diagonals. So now we're looking at diagonals of a parallelogram. So I need to have diagonals, and I need to have a word that says parallelogram. Bisect each other. So if you're bisecting each other, that means they're cutting each other in half. That means TM must be congruent to MR. And QM must be congruent to MS. All right, those are our three main theorems. That as soon as you read parallelogram, you should think all three of these things right off the bat. If I say parallelogram, think opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles equal 180, and diagonals bisect each other. So you should think all of those things, and in fact, that's what we're going to put right here. First of all, parallelograms have 4 sides. So when I say parallelogram, you should picture something that has 4 sides. Now you're going to picture all 4 of the sides having opposite sides being parallel and congruent. Opposite angles are going to be congruent as well. And consecutive angles are going to be supplementary. And their diagonals bisect each other. So I'm just going to draw a parallelogram off to the side. We're going to kind of mark it up, because this is what you should be thinking about every single time. I'm going to draw two things bisecting. All right, you should immediately think opposite sides are congruent. You should be thinking opposite angles are congruent. So that one, that one, that one, that one. And we should think that our diagonals are bisecting. The only thing I'm missing on this drawing is the most important part. Yes? Parallel. It is the thing that people miss most with parallelograms. When you're doing a proof, sometimes it's really important to state that it's parallel. All right, in fact, if I'm trying to say that two angles are supplementary, I first have to say they're parallel. So the definition of a parallelogram is that we have parallel lines. So let's put the parallel action going on here. So it's a lot of information from just one word. Parallelogram says all of that. And you have to think that every single time we say parallelogram. All right, let's do some examples with it. First of all, there's something really important missing from example number 1. In fact, I can't do anything until I state something. Can we see what's missing from example number 1 that would help me actually solve this? I need to know this in order to move forward. Krupa. That is a parallelogram. Does it say at all that it's a parallelogram? I can't do anything. You can't do anything until you know it's a parallelogram. So what we're going to do to this drawing is we're going to put little arrows on it.
But we don't know that they're parallel.
I'm putting it on. We're just saying this is part of the directions. Part of the directions should have these on. That's all it takes for it to be a parallelogram, or parallel lines. Or the directions might say something like let's go with SRQP is a parallelogram. That's another way I can say it's a parallelogram. Just dating it or putting it in the drawing. But once you have either one of those, then you're free to say it's a parallelogram and use those rules. All right, the first thing says that angle QPS is 70 degrees. So QPS is 70 degrees. So that's that whole angle here is 70 degrees. Before I do anything else, as soon as they give me it's a parallelogram and they give me 70 degrees, I mark all the rest of my angles. What is angle PSR? I don't know. 110, yes. So that's 110 degrees, which means Q, that PQR is also 110 degrees, which means that R is 70 degrees. So I have all that marked. Now what else I might do before I even read the question is, if this length is 5, what is SR? 5 as well. Because those two must be congruent, right? Because PQ and RS must be congruent, so this must also be 5. And if this little length of our diagonal is 3, what other segment is 3? Yeah. ST would also be 3. It's always good to just mark stuff up and then see if you answered all your questions. Yeah.
TR. Is that 3 too?
TR, we don't know that's 3.
Oh.
We only know that this cuts it in half. In fact, there's only one shape that actually has, and that'd be a square. Would have all 3 of these be the same. All I know is this is 3, this is 3. This is congruent to that, but I don't know what length either one is. It could be a 6 and a 6. All right, so let's see what questions we have. We have length of SR. Let's see if we answered that. Well, we said SR was 5, so we already answered that. All right, then it says find ST. ST is, well, we answered that too. It's 3. And finally, we did angle PQR. We're looking for the measure PQR. PQR is that one on the top right. We said that was 110 degrees. We had one more, QRS. QRS is that bottom right one, so that would be 70 degrees. And we did it all. Now we have extra stuff, Mark. That's okay. All right, example 2. It says PQRS is a parallelogram. Oh, good. It's parallel. So we know opposite sides are congruent, opposite angles are congruent as well. Find X and Y. So if opposite sides are congruent, that means this PQ is congruent to this SR. In other words, PQ is going to be equal to SR. Well, the length of PQ is just X plus 7, so we'll have X plus 7 equals my SR, which is 3X minus 10. Let's go ahead and subtract X from both sides. That will give me 7 equals 2X minus 10. Add 10 to both sides. And we are going to we're going to have 14 equals 2x. 14 divided by 2, x equals 7.
Isn't it 10?
Yeah.
10 equals 2x.
Mm-hmm.
But you wrote 14.
Yeah.
What did I do wrong?
X plus 7.
What did I do wrong? Davion. I put 14 instead of 17.
No. 14.
Oh, that's another mistake too.
Wait, what?
There's 2 mistakes in there. DJ.
Well.
Sometimes it's hard to find a mistake.
3x minus 3 and 3x minus 9.
Oh, 3x minus 3.
Yeah.
Oh, okay. So I started here. No, Davian, you're 100% correct here. I don't know why. My mind just made it so it'd be nice and dividing. I knew it was a horrible mistake. So it should have been 3x minus 3, right? This should have been a 3 here. But all the steps would be the same. I subtract x from both sides. We have 7 equals 2x minus 3. I would add 3 to both sides. 10 equals 2x. And x would equal 5. All right, cool. All right, 2y and the 3y plus 30. So in this one, I'm just going to put 2y equals 3y plus 20, correct? Is that correct? Are they both equal to each other? Disagree, Davion?
No, you should put 2y plus 3y plus 30 equals 180.
Oh, there's also a 30 in there? Oh, man. So many mistakes happening today. So we should have had 2y plus 3y plus 30 equals 180 because Q and R are supplementary. They are not congruent to each other, they're supplementary. S and Q are equal to each other. P and R would be congruent to each other, but those consecutive angles need to equal 180. They're supplementary to each other. So we have 2y plus 3y plus 30 equals 180, so that'd be 5y. Subtract 30 on both sides would equal 150, and y equals 30. With so many mistakes, is that the correct answer, or did I make other mistakes along the way?
That's right.
We're right. What can I do to check it? substitute it in. Do 2 times 30 equals 60 degrees. So that means this should be 120. Well, 3 times 30 is 90, plus 30 is 120. So in fact, I know those measures then. All right, questions on sides and angles? Yes, Krupa.
Because it bisects does it bisect the angles too?
No. Well, maybe. We just don't have anything that says it yet. And in fact, there's special ones that it does bisect. But just for now, they're not going to if it's just regular parallelogram. All right. Last one. We have FGHJ is a parallelogram. Awesome. That helps me out. We have FG equals 5. So as soon as I write down FG equals 5, what other segment equals 5? If FG equals 5, what other segment equals 5? So I'm going to go ahead and mark JH as being 5. Now let's do the other given. The other given is GK equals 3. GK equals 3. What other segment is equal to 3 then? Yeah. KJ. All right, and finally the measure of angle J is 70. J is 70, which means G is also 70, which means this H down here would be 110, and this F up here would also be 110. We'll see how much information we already have. We'll ask for JK. JK we already said was 3. It asked for JH. We already said that was 5. It wants the measure of angle G, which is 70 degrees, and the measure of angle F, which is 110. All right, questions on anything we covered right now? Again. Oh. You just stretched at the wrong point. All right, we're good? All right, the rest is homework for you to work on. You should have a good chance to get a bunch of it done. Ask questions.